everyone. Today we are going to study two subtopics of this lesson, organic chemistry, that are about the homologous series and isomers. So let's move ahead to study about them. Homologous series. So homologous series, it's a family of organic compounds with same general formula due to the same functional group that they possess. So when I say same general formula, if the general formula is CnH2n plus 2, then of course the molecule can have the formula of C2H6. Another molecule can have the formula of C4H10. So instead of n, when you are substituting the n with 2, the whole terms becomes 2 into 2, 4, 4 plus 2, 6. And then when you are substituting the value for n, which is 4, then 4 into 2, 8, 8 plus 2, 10. So this is general formula, and these are the molecules that comes in a homologous series. So that's a simple introduction for general formula. And then they are having the same functional group. So we are going to speak within a couple of minutes about the functional group, which is again an important point. And then homologous series, the molecules, as I said, it can be C2H6, C4H10. They follow a pattern in the physical properties. It can be the boiling point, melting point, then they do follow a trend, a pattern. And when we are speaking about the chemical properties, almost all the chemical properties of the homologous series, of the molecules in the homologous series are similar. So in our syllabus, the main groups of homologous series that we are going to study is alkanes, alkenes, alcohols, and carboxylic acids. And when we have to study about the polymers, yes, another functional group, another main functional group in homologous series, esters coming in, but we don't focus much about this because it's only it's a simple point that we have in polymers. So the main four functional groups that we are going to study in homologous series are alkanes, alkenes, alcohols, and carboxylic acids. So let's now move ahead. Functional group. As I said, now we are going to focus on functional groups. A functional group is a specific group of atoms or bonds. Atoms, it can be atoms, and then about the bonds within a compound that is responsible for the characteristic of the chemical reactions that they undergo. All right. So when we have a functional group, so if the compound that is given is, let's say, CH2, CH2, CH3. So here the functional group is this carbon-carbon double bond. So that's the reason for having the bond in the definition. Here the functional group is not carbon and carbon, but this double bond. The double bond plays an important role here. So here the functional group is carbon-carbon double bond. Or it can be a group of atoms. For an example, if we have C2H5OH, if I'm drawing the molecule, it will be C2H5 and then OH. Here the functional group in this particular compound is this OH, which is now a specific group of atoms. So functional groups are the responsible group of atoms or bonds that determine the characteristic of the chemical reactions that they may undergo. That's a short introduction to the topic functional groups. Let's now move ahead to study about our first type of functional group in the homologous series. So alkanes are compounds with carbon-carbon, important thing is single bond. And they contain only carbon and hydrogen, and their general formula will follow this. So when I have to have all the carbon-carbon single bond atoms, and when I have to follow CnH2n plus 2 as the general formula, if I'm having 3 carbons, and if I'm substituting the 3 over here, what I'm going to get for my hydrogen is 2 into 3 is 6, 6 plus 2, 8. So if I am drawing the hydrogens, I can see that I already have 3 hydrogens now. This is my 4th hydrogen. Here comes the 5th hydrogen, 6th one, 7th one, and 8th one. Yes, of course, this follows the general formula. Also, it has all the carbon-carbon single bonds of the functional group. And then it consists only C and H. Other than that, we don't have any other atoms here. So this is an alkane. So when we are speaking about the homologous series, in the series, the first compound that we can have is the compound with 1 or 2 carbon. Let's start with 1 carbon. If we have only 1 carbon, here we have 1, and then 1 into 2, 2, 2 plus 2, 4. Then I have my 4 over here. Normally we don't write this one. So the compound is CH4. So the first compound of the homologous series of alkanes is CH4, which is methane. And then when we have 2 carbons, then if you are substituting 2 instead of N in the general formula, then it will become C2, H2 into 2 plus 2. So the whole terms become 6. Then the next compound in the homologous series that we have is C2H6, which is, this is methane, this is ethane, methane, ethane. And then when it is 3 carbon, then as I said, we will have 8 hydrogens, which will still follow the general formula. So H8, propane, then C4, H10, butane. So about naming the compounds, we are not going to study in this particular presentation, but of course, in our continuing lessons, we will be studying about them. So 1 carbon and alkane, so that you can look at the trend, it ends with the term ane because these are alkanes. So methane, ethane, meth stands for 1 carbon, eth is for 2 carbons, for prop for 3 carbons, and for 4 carbons. So methane, ethane, propane, butane, and moving ahead, if you have 5 carbons, pentane, hexane, heptane, it will keep on going like this through the homologous series of alkanes. Now let's have a look at the homologous series of alkenes. Alkenes are still the same like alkanes. The only place where it differs is instead of having carbon-carbon single bond, this time we are going to have carbon-carbon double bond. So completing the rest with hydrogens. Here I have 3 hydrogens already. And an important point that I have to remind over here is a carbon can have 4 bonds in maximum. I can't draw the 5th bond. No, it cannot be done. So 4 bonds in maximum. So I have completed 4 bonds for this carbon. And already there are 4 bonds for this carbon. This particular carbon, we already have 4 bonds. 1, 2, and then 3, 4. So I am not supposed to draw a bond, which is the 5th bond. So only 1 hydrogen is attached to the 2nd carbon. And over here to complete 4 bonds, I can draw 2 more bonds. So here is the hydrogen, here is the hydrogen. Then C3, 8, 6 is what I'm getting. 1, 2, 3, 4, 5, 6 hydrogens. And if we are looking about the general formula, when we have 3 instead of N, then H is 2 into 3, which is 6. Yes, this is correct. So you can now pause the video and try drawing the alkene with 4 carbons, which will have the name butene. Butene, it's because ene, so ends up saying butene. Try drawing the alkene with 4 carbons and check whether the structure that you are drawing still follows the general formula by the number of carbons and by the number of hydrogens. All right, so we are good to move to our next functional group, which is alcohol. So alcohol, it is the compound with functional group OH functional group. So the functional group that we are going to have this time is OH, and it still contains only carbon, hydrogen, and oxygen. Contain only carbon and hydrogen. In addition to carbon and hydrogen, it now has oxygen, and the general formula will be CnH2n plus 1 OH. So let's work on that. If I have OH group as my functional group, let's say this time I'm having 3 carbon and here comes my functional group. So competing rest with hydrogen, I have 5, 6, 7 hydrogens. So C3, H2 into 3, 6, 6 plus 1, 7. So yes, I have 7 hydrogens, and then OH. Sometimes this can be further simplified and written as C3H8O, adding this H with this part and writing the O separately. So functional group is OH for alcohols, and if we have 2 carbons, 1 carbon and 3 carbon, 4 carbons, then the names are given as methanol, ethanol, propanol, butanol, pentanol. So since the functional group differs, now we are having this OL term, ethanol, methanol, propanol, this OL term coming in naming nomenclature. All right. Then here we have the functional group, the last functional group that we are supposed to study in today's session, which is carboxylic acid. So carboxylic acid is having the functional group C double bond OOH, C double bond OOH, nothing other than that. So compounds with functional group C double bond OOH, which can be written as COOH, are called carboxylic acid. They still contain carbon, hydrogen, and oxygen, and their general formula is CnH2n plus 1 C double bond OOH. So instead of OH, which is coming over here for the alcohols, this time we have C double bond OOH. So when we have 1 carbon, here comes the next functional group, 3 hydrogens. So C1, and then our H has to be 1 into 2, 2, plus 1, 3. So 3, yes, see, we have 3 hydrogens, and the functional group C double bond OOH. So this is only 1 carbon. So this is methanoic acid. This is methanoic acid. And now as a work, what you can do is pause the video, draw the structure, and check whether it matches for the general formula for the carboxylic acid functional group compound with 4 carbons, which will now be called as butanoic acid. All right, then we are moving to the topic isomers. We are going to have a quick look on isomers. So isomers are the compounds with the same molecular formula but different structural formula. What I mean by that is, now let's think about propanoic acid, and when it is oic acid, we know the functional group has to be C double bond OOH, and prop is prop, so 3 carbon. Then the structure will be 3 carbon, and then this functional group. So here we have altogether 7 hydrogens. So the structural formula and the molecular formula. Molecular formula is what we are writing as a formula over here. So for this particular compound, this is C3H7 C double bond OOH. Okay, this is our molecular formula. So let's say I'm having the same molecular formula, but different structural formulas. Let's see how I can have that. So here again comes the same molecular formula. But when I'm trying to do that, what I'm going to do is, let's say this is a straight chain. This is a straight chain, and at the terminal carbon, I have my functional group, which is C double bond O, OH. And over here, the rest are filled with hydrogens. But over here, what I'm going to do as this difference is, my functional group, the functional group, which is ionic acid, this time is attached to the middle carbon as a branch, and here I have the rest of the hydrogens. Still I have 7 hydrogens, 1, 2, 3, 4, 5, 6, 7. So if we are looking at the structures of these two compounds, the structures are different, but still the molecular formulas are the same. So isomers, these are isomers to one another. That's pretty much it about homologous series, functional groups, and isomers. Let's meet in another presentation. Thank you very much.